Welcome. My name is Rachel Jones. I am a professor in the Department of Environmental Health Sciences at the University of California, Los Angeles Fielding School of Public Health. This module is Determinants of Exposure. Upon completing this module, you will be able to define the term exposure determinant, identify common exposure determinants, explain how exposure determinants can influence the magnitude and variability of exposure, and apply IHEST, a computer software package, to document exposure determinants. An exposure determinant is a factor, condition, or practice in the workplace that strongly influences the magnitude, frequency, or duration of exposure. That is, if the exposure changes when a condition in the workplace is changed, then that condition is a determinant of exposure. Some factors and conditions commonly recognized as exposure determinants are properties of materials, environmental conditions, control strategies, operating conditions, and work organization. Two properties of materials that are determinants of exposure are vapor pressure and dustiness. For the same process, a material with a lower vapor pressure or higher level of dustiness will tend to increase the emission of material into the air and thus increase exposure. Environmental conditions like temperature, relative humidity, and airspeed can affect the behavior of materials in the workplace, but they can also impact the activities of workers. For example, increased temperature will tend to increase emission of volatile chemicals, increasing exposure, but increased temperature may also slow the work rate of workers, which could increase or decrease exposure. Airspeed, such as produced by ventilation or wind, may influence the direction and dispersion of plumes, thereby affecting exposures. The presence, use, and effectiveness of control strategies can influence the magnitude and frequency of exposures. Process containment and local exhaust ventilation systems are designed to prevent the release of contaminants into the work environment, so as to reduce exposures. However, performance of these systems may decline over time, or they may not be used effectively. Gloves can prevent dermal exposures, but exposures may occur if the wrong glove material is used, the glove is not changed out on schedule, or simply not worn. Respiratory protection may reduce exposures to airborne contaminant concentrations, but the anticipated effectiveness of the respirator may not be achieved if the respirator does not fit, the wrong cartridges are used, or the cartridges are not changed out on the right schedule. Processes do not always operate under normal conditions. Production rates may be increased or decreased depending on the demand. There may also be process upsets, and maintenance activities may be undertaken, such as to clean or repair equipment. All of these situations may impact workers' exposures and thus be exposure determinants. I use the phrase work organization here to refer both to the physical organization of the workspace and the job organization. Physical organization influences the proximity of workers to sources of exposure and can therefore influence the magnitude of workers' exposure. Job organization defines which task each worker performs during a shift and how long workers perform each task. Both of these factors can influence the magnitude, frequency, and duration of exposure. It is important that industrial hygienists recognize and record information about exposure determinants. This information can be used to help plan exposure monitoring strategies. For example, the hygienist may want to conduct sampling when a process is operating with the dustiest materials or at the highest production rate to try to capture a worst-case exposure scenario. This information is also necessary to interpret exposure data. For example, if workers turn on or adjust the positioning of a local exhaust ventilation system, if information about the system is not recorded, then it will be known if the measured exposure data reflect exposures that occur with or without the local exhaust ventilation. By recording this information, the hygienist will also be able to use the exposure monitoring data to verify that the local ventilation system remains effective over time. It is recommended that information about exposure determinants be added to audit documents and to exposure monitoring data collection forms. These strategies will help to ensure that exposure determinants are collected regularly and in a consistent way over time. If these pieces of information are collected only sporadically or recorded in inconsistent ways over time, it can be difficult to use the information to interpret exposure monitoring data. The IH Exposure Scenario Tool, or IHEST, is a free tool available through the American Industrial Hygiene Association. The website link is shown on the slide. The IHEST is an Excel workbook tool that uses macros. The tool uses a series of worksheets to capture the organization information that should be obtained in a basic characterization of a workplace exposure scenario. For the purpose of IHEST, a workplace exposure scenario can be thought of as a job task that is anticipated to result in worker exposures, such as filling a drum with a liquid or powder, welding stainless steel in a fixed location, monitoring an additive printing operation, or mixing anti-neoplastic drugs in a fume hood. This image is the cover page of the IHEST tool. The tool has 4 steps. Step 1 gathers information about the workplace exposure scenario. Step 2 gathers basic characterization information. Step 3 gathers exposure determinants. And Step 4 gathers the results of exposure monitoring data, including those related to inhalation of airborne contaminants, dermal exposure to contaminants, and noise. The exposure determinants that I have discussed in this module are gathered in Step 3, but also in Step 2. This image shows the IHEST Exposure Determinants Worksheet section for inhalation exposures. The form collects information about ventilation that may affect exposures associated with the scenario, including the type of ventilation, measured ventilation rates, and measured air speeds. The form also collects information about the physical layout of the room, including the number of sources. Generation rate describes the amount of contaminant that enters the work environment per unit time. Generation rate is a determinant of exposure that may be influenced by the production rate, effectiveness, containment or local exhaust ventilation, temperature, and other factors. It can be difficult to quantify a generation rate. Chemical usage rate is related to the production rate. Step 3 of IHEST also collects information about determinants of dermal exposure, as shown in the image. This includes the portion of the body that are exposed and thus may experience dermal exposure, along with the duration and frequency of dermal contact with the chemical. The chemical retention time refers to how long the contaminant may be on the skin. This information, along with the concentration of the chemical if present in a mixture, and the contact areas may be used to calculate the magnitude of dermal exposure and uptake into the body. Step 2 of IHEST is the basic characterization, but this step collects information about a number of additional exposure determinants. The image depicts the scenario description section of Step 2. Here, the hygienist provides a narrative describing the exposure scenario and exposure controls. SEGs, or similar exposure groups, are explained in other modules of this exposure assessment course. The form also gathers information about the proximity of workers to the source and the amount of time workers spend close to the source and in the work area. Step 2 also gathers information about the chemical agent of concern. Here, the hygienist provides a narrative describing the chemical of concern and the chemical physical properties that govern chemical behavior and may influence exposure. Process temperature is recorded, which is an exposure determinant, as it can influence chemical evaporation. To conclude, an exposure determinant is a factor, condition, or practice in the workplace that strongly influences the magnitude, frequency, or duration of exposure. In this module, we have described that material properties, environmental conditions, control strategies, operating conditions, and work organization may all be determinants of exposure. Recognizing and identifying exposure determinants is important to interpret exposure data and identify opportunities to control or reduce exposures. For example, if vapor pressure of a chemical is identified as an important exposure determinant, and exposures are found to increase on days with warmer temperatures, this could suggest a need to substitute the chemical for one with a lower vapor pressure or improve temperature controls in the workplace. If temperature is not recorded when the exposure monitoring data are collected, it will not be possible to associate the high exposure measurement with temperature, and that exposure may be incorrectly attributed to some other potential exposure determinants.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.